Hi and welcome to another tutorial video. In this tutorial video what I'm going to be doing is talking about syntax diagrams in relation to BNF. And what syntax diagrams are a way of graphically representing the production rules that I talked about in the previous tutorial video on BNF. Okay, so what sort of symbols do we use to produce these syntax diagrams then? Well, first of all, there's the oval symbol, which is a terminal element which cannot be broken down further. So, what does this mean? Well, if I was defining, say, a digit, this is one of the production rules that I had in the previous tutorial video. I might define a digit by using this oval symbol. So we draw an oval and we put a 0 in there. But a 0 is not the only thing that a digit can be. So we would draw one of these for each of the fundamental things that a digit can be. So these are the digits 0 to 9. And that's what this oval represents. It's a element in our BNF which cannot be represented by another syntax diagram. Okay, so excuse my rather badly drawn syntax diagram there, but basically this BNF production rule here is equivalent to this diagram here. So what I've done is I've drawn an oval and placed inside the oval each of these fundamental things that a digit can be, so fundamental digits. That can't be broken down any further into and defined by other BNF production rules. And I've said that we can work out if something's a digit by if we can get from this entry point here to this end point here. So if, say, for example, I was trying to work out whether A was a digit, I would start at this entry point here and I would look down my column here of fundamental things that a digit can be, and say, can I pass through any of these? Is my A any of these? And I can't pass through any of these because my A isn't a 0, a 1, 2, 3, 4, 5, 6, 7, 8 or 9. So my A is not a digit. That's how you draw a syntax diagram for one of these simple BNF production rules, where we're just saying that that something here is defined by some fundamental things here. Okay, so I'm going to leave that diagram of digit over there for now because we're going to use it later in this video. So next we've got the next key symbol that we can use in our syntax diagrams is a rectangle. And a rectangle is a non-terminal element, and what we mean by that is that it can be defined by some other syntax diagram. So an example of this would be our digits here. So if we were to include digit in another syntax diagram, we would draw it in a rectangle like so. So to include digit in another syntax diagram, we'd draw it in a rectangle like that. And then imagine we've got part of a syntax diagram that's got something going on over here, something going on over here. We're just concerned with this bit that we've got digit in. We come in here and we can refer to our other syntax diagram here as to check whether the thing we're trying to validate is in fact valid, because this in itself doesn't tell us what defines a digit. We have to look at our other syntax diagram over here. And we can also define a non-terminal element like digit that can be used more than once. So to do that, we draw the same rectangle as we did before, but we have an arrow which starts at the line coming out of the rectangle and goes back to the beginning. So that's relatively straightforward. If our BNF definition says that whatever we're defining can have more than one digit, we can use an arrow to represent that. So let's look at a simple example here, and then I'll move on to showing you how we can represent the BNF definitions that I talked about in the previous BNF tutorial with syntax diagrams. And I've already started that off by drawing this syntax diagram of digits over here. So we've got this BNF production rule digit here. I'm going to write another BNF production rule which uses digit. Okay, so imagine that natural number is on the same line as that digit there. So this is a production rule to define a natural number. Okay, and what this BNF production rule for a natural number is saying is that a natural number can be a single digit on its own, or a digit and a natural number. So what does that look like in terms of a syntax diagram then? Well, we've got the definition for a digit over here, so we can just do a syntax diagram for natural number and use our definition of digit that we've already got. So this syntax diagram here is defining a natural number. And what it's saying is that a natural number has to have at least one digit, because to get to the end of the diagram we have to go through the digit non-terminal element. But it can have more than one digit, so we can follow this path in the diagram around back to the start of the diagram before digit and pass through digit again. So it's saying the same thing as this recursive BNF definition. It's saying that a natural number can be composed of one or more of these digits that we've defined in this syntax diagram over here. Okay, so this is the set of BNF production rules that I used in my previous tutorial video, and I would urge you to refer back to that tutorial video if you're not sure what these definitions mean. We can see we've already got digit defined over here in a syntax diagram. Now what I'm going to do is show you how to define variable first. So we're going to define variable in a syntax diagram, and the way I would define letter, we're going to assume we've already defined letter, because the way I would define letter is fairly straightforward. I've cut it down for this example from what I had in the previous tutorial. In this example of BNF, I've got a letter to be any lowercase letter, and we would just do it in exactly the same way as I've done the digit diagram. With one of these rows in this column with an oval and that particular letter in. So I'd start off by doing something like this. And I'm not going to carry that on because I think that's fairly self-explanatory. It's exactly the same as defining a digit, except instead of digits in that, like I've got in that diagram, I've got letters in this diagram, so I'll continue doing this for all of the letters that I've got in the BNF here. So this syntax diagram here is how we would define a variable. And we can see to get from the entry point here to the exit point here of the diagram, we have to use at least one letter from our letter definition that I talked about a minute ago. And you'll also notice that before we can leave the diagram, we can use as many digits as we can by following this by following this path right here, and we can loop back around to the start of the diagram and use as many more letters as we want. And this maps directly to the BNF, because in our BNF a variable can be a letter, a variable and a digit, or a variable and a letter. Okay, so let's make sure this syntax diagram that I've got over here is correct. So what I'm going to do is go through three examples of things that we want to test, whether they're variables or not, whether they're valid variables, that is. And first of all, I'm going to start with hello. So is hello a valid variable name? Well, if we start at the beginning of our diagram, we can have a letter, and H is a letter according to our definition of a letter, so we pass through here. Then we get to this point in the diagram, and we also want to have another letter, which is E, So we move around the diagram and add another letter. And we continue doing this until we add L, L, and O like that. And this diagram maps straight onto the BNF. So we can reason using this BNF definition up here that hello is also a valid variable name. So if we take H, for example, H is a letter and is therefore also a variable because a variable can be a letter. E is a letter and is therefore a variable since a variable can be just a letter, and therefore HE is also a variable because H is a variable and E is a letter, and a variable can be a variable and a letter. So we know that HE is a variable, and then we take a look at L and we see that L is a letter, and since we know that HE is a variable, we know that HEL is a variable and a letter because a variable can be a variable and a letter. And then so now we know that HEL is a variable. Taking a look at L again, the second L, we know that L from this definition here is a letter, and therefore because HEL is a variable, we can reason that HELL is also a variable because a variable can be a variable and a letter. And finally, because we know that HELL is a variable and we know that O is a letter, we know that hello is a variable because a variable can be a variable, HELL, and a letter O. So let's take a look at how HI1 could be reasoned to be a variable. So H is a letter and therefore H is also a variable. I is a letter and therefore HI is a variable because H is a variable and I is a letter. HI we know is a variable now, and 1 we know is a digit. So HI1 is a variable because a variable can be a variable, HI, and a digit, the 1. And we can see that our syntax diagram works for the example HI1 as well, because we start at the entry point to our syntax diagram, we move through here, and we can have a letter to start off our variable, and that is going to be H in the case of HI1. Then we move round and we loop back around to the start of the syntax diagram, and we add another letter, which is I. Then we pick this path here and we loop around here and add a digit, a 1, and then we exit our diagram. And then finally this example here, 1HI. Well, we can see that 1 is a digit, but 1 on its own is not a variable because a variable can not be just a single digit on its own. And this is shown by our syntax diagram as well, because if we start at the entry point here and move along here, we hit a letter, and 1 is not a letter. So whereas in BNF we've got these recursive definitions to handle this sort of production rule, with these syntax diagrams, these recursive definitions that we've got in the production rules, in the BNF production rules, become a lot clearer. Okay, so I'm just going to go through one final example before I end this tutorial video here, and that is defining an initial. So you can mix the use of the non-terminal elements and the terminal elements, and this BNF definition here defines an initial as a letter and then a dot. So I'm just going to imagine that I've defined a syntax diagram for a letter similarly to the way I defined digit a minute ago, and a letter can be any letter between A and Z, so any uppercase letter between A and Z. And the way I draw this syntax diagram is fairly straightforward, just an entry point here, a letter, and then a terminal dot there, and then a exit point. So we can see that an initial, according to this diagram, we would have to have a letter, and we entered it from this point here. We'd have to have a letter, and then we'd have to have a dot, and then we'd have to exit. So a valid initial could be something like that, but that wouldn't be a valid initial because letter is a character between a capital A and a capital Z. Okay, so that example was just showing you that you can mix the non-terminal elements, the rectangles, with the terminal elements, the ovals in your syntax diagrams. Okay, so that brings us to the end of this tutorial video on syntax diagrams. I hope you found this tutorial video useful, and thanks for watching.